there is an issue that we wanted to analyze a single instance, right, of this whole thing, right? But we have a problem because this signature this signature is used for many key exchanges, right? So this is signature. This is my long-term verification key, and I'm using the corresponding signature key in all my TLS connections, right? And not just this one. So all of a sudden, this nice separation that I did, and I would just want to do a single session and forget about everything else, doesn't work anymore, because all my sessions are kind of connected, they're not independent things, right? Remember what I drew this nice picture before about the protocol having, I can only talk about with parties within my subgraph for this protocol thing, and now I actually talking about have many different protocol instances that that actually have to talk to each other, right? So what do I do with that? Right? So I have now one session. So session one with and this is a secure session, and underneath there is a key exchange, and we talked about let's say encryption. Sorry, let's call it here encryption, and underneath there is authentication, and under everything there is a key exchange, and this key exchange now is using a signature module, and this signature module is using a CA. In fact, already in the same signature module, which is the same secret key signature, is going to be used for a different session. All this tower of things is the same signature that's within one party, and many of them all use the same signature module. And now those guys cannot be treated as separate protocols for the purpose of DC, because there is one join that talks to all of them. Okay, so kind of lost my composability, my ability to decompose things. So how do we deal with that? So there's a trick to do it, and it's called UC with joint state, or JUC, people call it. And what is the trick? The trick is that I want to say the following. Look, it's true that this signature module is combined, is the same for all three, all of them, all those different sessions. But if I'm looking more closely at what this signature module gives me, what does it give me? So let's look at it a bit more closely. So this signature module, what does it do? It gets a request to sign something, right? And if I do it ideally, I'm giving you an ideal signature. I get a sig of M, and I also I put here not just M. I not just sign the message that you ask me. You also give me your SID, and I'm signing M and your SID together with it, just to make sure that this signature is for you. And the same I'm doing for this, and the same I'm doing for that, right? This is my joint signature. I claim now that from the point of view of these guys, they don't care. I mean, everything else looks the same as if they didn't talk to this one single signature module, and they actually talked each one to their own independent signature module. Because why? Well, one has to prove it, but essentially the point is the one salient point of the signature here is the unforgeability. And unforgeability works in the same way whether this is a single signing key signs all of them, or each one of them is signed with a different signing key. The same unforgeable in exactly the same way. Why? Because I put the SIDs inside. So kind of like did kind of a separation between signatures for the different instances.
Can you say that again?
Okay. So what I'm saying is not completely formal. One is to do it more formally. But I'm saying from the point of view of these, of all the key exchange protocols, I'm saying they don't care, or they see the same thing, regardless of whether they all talk to the same signature model, use the same key to sign all of them, which is happening in reality, or if they actually talk to another system, which doesn't exist, but in that system, each one of them had their own signature key. So I'm saying, so from the point of view of what they care about, which is unforgeability, it's exactly the same. It's unforgeable in the same way. And there's no additional information in the signatures other than the unforgeability. And you can actually show it when you move to an ideal signature functionality. And there's a theorem that says that if you have, if you can show if you can show that this this one signature, the one combined signature that signs, say, with the SID, emulates a more idealized protocol which has multiple independent signatures, multiple independent keys. If this protocol emulate that protocol, okay, then I can do this trick of analyzing all those protocols as if they have access to that protocol, and then later replace that protocol with a joint one, and it's guaranteed that it will continue looking the same. So again, so what I'm going to do now, I'm going to analyze, continue analyzing each session as if it's the only one in the world, nothing else exists. In particular, each session now have its own signature key that's independent from all the other signature keys. And I'm just doing the entire analysis of the entire thing under this assumption, right? And then I'm going to replace this, system, which all of these three guys have, each one has his own signature key, with a joint signatures key, and which emulates this three independent keys module, and then this joint state theorem says that if I replace these individual signature protocols with a joint one, then the entire composite system, which now has joint state, still emulates the original one, the ideal one, which didn't have joint state. Okay. So again, so this allows me to continue doing the analysis on each session separately, and still use something joint, as long as this something joint really has this functionality that looks like, you know, three independent things. So that's the idea.
So is JUC, is it a different underlying model, or does this?
No, it's all within the same model. It's the same model, same everything. It's an additional theorem. Okay. An additional composition theorem. In addition to the one that we talked about before, it's addition one. It uses the original one. It's kind of another small layer, you know, thin layer on top. But it's an additional.
Yeah, I've seen papers say it's secure in the JUC model, but that's the same as the JUC model.
Right. Same model, just different property, different theorem on the same model. Okay, so it allows you to do it, and it allows you to do it in other things. And in a minute, we'll talk about the project. There's one place where I think it's actually going to be useful there too. I'll say a word about it. Yeah.